For this problem, we're just going to be looking at how to set up a couple of word problems. So the first thing we want to do for any sort of word problem is determine what are our variables. So in this case, we're looking at Buffalo Bob, who rents canoes and kayaks, and he's got some money to buy some new boats. We've got the price of those boats and the amount he rents them for, and he's got just a little bit more room in his shop. We want to know how many of each boat he should buy to maximize revenue. Now, your variables are always the things that we don't know, the things that we're trying to find. And that's generally in the last sentence of the question. So we see how many of each type of boat should he buy. So let's let x equal number of canoes and y equal number of kayaks. We don't want to say x is just canoes and y is kayaks because there's a lot of different things about canoes and about kayaks that we could be talking about. There's the cost of the canoe, there's the cost to rent the canoe, there's the number of. So we want to be very specific when we say what our variable is. So in this case, x is number of canoes, y is number of kayaks. Okay, so the next thing we want to look at is our totals. So we're going to have two totals. In this case, first one is he has $45,000 to purchase new boats. So the first equation is going to be 45,000 on the right-hand side. Now he wants to use that amount of money or less, so that's going to be less than or equal to. And we want to look for, in this case, since 45,000 is the cost to purchase boats, we want to look for the costs to purchase the different types of boats. So canoes are $600 each, kayaks are $750, so that's going to be 600x plus 750y. All right, the next one is going to involve the number of boats that he can fit in his shop. He can only fit 65 total boats, so that's a total number between canoes and kayaks, and so that one is just going to be x plus y is less than or equal to 65 because the total number of canoes and kayaks cannot be more than 65 or he won't have room for them in his shop. All right, the last part is our revenue equation. We're trying to maximize revenue, and we know that Buffalo Bob's charges $25 a day to rent the canoes, $30 a day to rent the kayaks, and so those are going to be where our revenue numbers come from. So $25 a day for canoes and $30 a day for kayaks, and that is going to be our z equation, our optimization equation. So this is how we would set up this problem. All right, let's take a look at another one real quick. We've got a 4-H member who's going to raise some pigs and goats. She wants to raise no more than 16 total animals and no more than 10 goats. And then we've got the cost to raise each one and how much profit she'll get from each one. And she has $900 to raise animals. How many of each animal should she raise to maximize profit? So we see the word maximize, so we know that this is a linear programming problem where we'll have some linear inequalities and a maximization equation. Again, the first thing we want to do is find our variables. Variables are goats and pigs, but more specifically, if we look at the last sentence, how many of each type of animal? So we're going to say x is number of goats, and y is number of pigs. All right, so first thing we want to think about are our totals. So the first thing we see is that she has $900 to raise animals. So that is the most she can use to raise animals. So that's going to be less than or equal to, because she can spend less than 900, but not more than. And we want to look, that's the price to raise animals, so we want other numbers that talk about raising animals. So $25 to raise a goat, $75 to raise a pig. So that's 25x plus 75y. So again, $25 to raise a goat, $75 to raise a pig, $900 to raise animals altogether. We always want to make sure the units are the same throughout the entire equation or inequality. All right, we also have a total of 16. She wants to raise no more than 16 total animals. In this case, it's just going to be x plus y, the number of goats, plus the number of pigs. We want to be less than or equal to 16. Now there's one other total, and it's not exactly a total because it's just one thing. She wants less than, no more than, 10 goats. So goats are x, so we want x to be less than or equal to 10. We don't want any more than 10 goats. All right, so then we want to maximize profit. So we know that our objective equation, our z equals equation, is going to be talking about profit. And so in this case, she will make $12 in profit from each goat, so that's 12x, and $40 in profit from each pig, so that's 40y. And so this is how we would set up this problem.